Okay, here is an extension video. This is for anybody planning to head into the pre-calculus. You will be expected to know this stuff, but it won't explicitly show up in our power assignments. All right, so there are two right triangles that are considered more special than others. We call them special right triangles. The 45-45-90 and then the 30-60-90. Now, they're special because of where they come from. Because you may have noticed, well, hey, this is not a triangle, and this is not a right triangle. You are, of course, correct. But using these shapes, we can determine some relationships that are always going to hold. For example, in this square, we know we have a right angle down here. I also know that in my square, all my side lengths are the same. So just for ease, I'm going to say this has a length of 1, therefore all the sides have a length of 1. The way you get your 45-45-90 triangle is to say, take this triangle, let's draw in the diagonal, and then let's figure out how long the diagonal is. Using your Pythagorean theorem, 1 squared plus 1 squared equals, let's call this c squared. Well, 1 plus 1 is 2. Do a square root, that means that c is the square root of 2. Furthermore, when you take a square and put in a diagonal, you've taken this 90-degree angle in the corner and you've split it exactly in half. So here is our first special right triangle. It comes from a square, 45-45-90. The two leg lengths are the same, and then the hypotenuse is square root of 2 times as long. So if instead of 1s, these had been 3s, then the length of the hypotenuse would be 3 times the square root of 2. The second special right triangle comes from an equilateral triangle. In an equilateral, you've got 180 degrees divided equally amongst the 3 corners. Therefore, each of them is 60 degrees. Then let's imagine taking the top point and dropping an altitude straight down to give us a right angle. Take 180 minus 90 minus 60. That means you got 30 degrees left up here in this top corner. It's just the top 60-degree angle split exactly in half. Now let's look at the side ratios. Now just for right now, I'm going to call all the side lengths 2. And I think you'll see why I do that here in a minute. Because if we take a 2, and if you split it right down the middle, that means that just this half of it has a length of 1. So in a 30-60-90 triangle, the hypotenuse is always twice as long as the shortest leg. And then using the Pythagorean theorem, we can figure out the length of this other side. So 1 squared plus b squared equals 2 squared. Well, let's see. That's 1 plus b squared equals 4. So b squared equals 3, and b is the square root of 3. Okay, the length of this altitude is square root of 3, and there is special right triangle number 2. So they're special because of where they come from. Your pre-calculus teacher is going to expect that, let me move this up a little bit, that you have these two things memorized. In a 45-45-90, let me label my angles here. The two legs are the same, and then the hypotenuse is square root of 2 times as long. In the 30-60-90, the short side is always half the length of the hypotenuse, and then the long leg is square root of 3 times as long as the short leg. So, how do we use this? Here's how. To find missing side lengths exactly, meaning in terms of square roots. Now, using the methods we talked about in an earlier recording, you would get decimal answers, which are perfectly good for most things. In pre-calculus and calculus, we sometimes want the exact in terms of square root results. So let's give this a look. Several ways to do this. Here's what I think is the easiest. When you want to use our special right triangles, I'm going to take a look at how this one's drawn, and I'm going to make another copy right beside it. Look how perfect that is. And it's a 45-45-90, so I know my side ratios are 1, 1, and square root of 2. I can then use this relationship to set up proportions that allow me to solve for missing sides. Here's what I mean. In this triangle, the x compared to the 8. So notice it was the right side to the hypotenuse. Well, that's going to be the same ratio as the 1 compared to the square root of 2. This is an equation now that you can solve. Cross multiply. So x times the square root of 2 equals 8. Divide by square root of 2. And there you go. You, my friend, have your x length. Coincidentally, you also have your y length, since x and y are the same. For me, I'm okay if you leave it like this. This is, it's not called unrationalized, but it's unrationalized. This, however, is not how the answer will look on the answer key. To do that, for a long time, it was important not to have square roots in denominators, and so that's a process that's kind of carried forward. The answer that shows up on the answer key is equivalent to this. So real quick, I'm going to pull up a calculator just so we can see that 8 divided by square root of 2 as a decimal. Okay, it's about 5.656. There's an alternative form here that doesn't have a square root in the bottom, and that's what's going to show up on your answer key. Whenever you got a square root down below, you can get rid of it by multiplying by that same root top and bottom. On the top, you've got 8 square root of 2. On the bottom, square root of 2 times square root of 2 is square root of 4. Square root of 4 is just the number 2, no more square root. We call it rationalizing because it removes square roots, which tend to be irrational. Finish up, do 8 divided by 2, and you got 4 square root of 2, which you can then see is equivalent to what we had before. So, to clarify and specify, what you see on the answer key will be this. Many of your teachers in future years expect you to be able to get this. For right now, I don't care if you want to stop there. That's that whole story. Okay, let's go again. Using this same procedure, we're going to set up a similar right triangle. So a 30, 60, 90, oriented the same way. My side ratios are 1, 2, and square root of 3. We can now use the similarity between these two shapes to set up some proportions. So let's do x first. So x compared to, let's go, x compared to 2, right? So hypotenuse to hypotenuse, x compared to 2 is the same as this length compared to the corresponding length in the other triangle. Lots of different ways you can set up a proportion that makes this work out. You choose whichever proportion you like best. Okay, so square root of 6 over 3 over 1, well, dividing by 1 doesn't change anything. So this is really what we have. You can then do a cross multiply and solve. So 3x equals 2 square root of 6. Then divide by 3. So x is 2 square root of 6 divided by 3. I hope that's not a shock to you. Remember our ratios? The hypotenuse is always twice as long as the shortest leg. So you take this, multiply it by 2. That's what we got. Now for the y, let's do something similar. So y compared to the square root of 3 is the same as this side compared to the 1. And we already saw that dividing by 1 didn't change anything. Okay, so do a cross multiply now. So 3y equals square root of 18. I do expect that you are able to reduce this radical. So let's just think off to the side here for a little bit. 18 is 9 times 2, and the square root of 9 is just 3. So the square root of 18 simplifies to 3 square root of 2, divide by 3, and we've got y equals square root of 2. Okay, there that is. So please don't skimp, but also don't overcomplicate. Draw a new triangle, set up a proportion that will allow you to solve for what's missing. Now for this last one, I'm actually going to show you another way to do it. This is how I like to think about it because I've got my ratios committed to my memory. What I do is I take a look at what I have. I know here I've got the long leg. Well, okay, I know that to go from the short leg to the long leg, you multiply by square root of 3. That means that to go in the other direction, you just divide by square root of 3. There it is. I then can rationalize this. So if we multiply by root 3 top and bottom, it's going to give me 4 square root of 3 over 3. There's your short leg. And then to get the hypotenuse length, just take your short leg, double it. Take it times 2. 2 times this is just 8 square root of 3 over 3. There they are. So as you're going through, the manipulations can sometimes look a little tricky. Make sure you're checking the answers as you go. If something isn't working out the way you think it should, then check in with a friend or neighbor or check in with me.